visiting amarpathshala.com. Today we are going to discuss the chapter Chemical Bonds and the Structures of Substances, and this is part 1 of the lecture. All atoms usually forms bond with other atoms. That is the nature of chemical substances that we learn in chemistry. However, this is not the case in case of 6 special elements. These elements are found in group 0 or group 8 of the periodic table. They are so unreactive that these elements are known as inert gases. You will find them at the extreme right of the periodic table. And these elements are helium, neon, argon, xenon, krypton, etc. Now, what makes them so unreactive? Why are they so inert? The answer lies in their electronic structures. Take helium, for example. Helium has an atomic number of 2. Helium has a symbol of He and it has an atomic number of 2. Now, if we were to draw the electronic structure of helium, we will get something like, if this is the first shell, and this is the nucleus wherein the protons and the neutrons are, the electronic structure would be something like this. 2 electrons only, 2 protons, and so as you can see, in the first shell there are 2 electrons, and as we know from learning basic chemistry in previous chapters, the first shell is filled after it has 2 complete electrons. So the first shell is filled. There is no more space for other electrons, and it has attained a stable structure already. So since it has such a stable structure, and with 2 electrons, it is supposedly very, very small. Such a structure, such a build-up makes it very hard to lose an electron and take part in a reaction. It's the same with all the other noble gases or inert gases. Another name for the elements in group 0, group 8 is noble gases, because they tend to be so unreactive, so decent, and so noble. And so, in case of other gases, say neon for example, neon with the symbol of Ne has an atomic number of 10. So if we are to break it down to its electronic structure, how its electrons are electronic configuration, how its electrons are arranged, we will get 2, 8. 2 in the first, 8 in the second. This again, in my previous lecture I have mentioned that after the first shell, in the second, third shell, they tend to be full when the shells have a complete of 8 electrons. If you go even higher than third, fourth, fifth, sixth, they tend to be completely full with electron arrangement of 18. But we won't go there right now. So in the first shell it has 2, so it's filled up, and in the second shell it has 8. So the second shell is also complete. A complete second shell with 8 electrons is known as an octet. So noble gases are structures which has either a complete duplet, meaning 2 electrons in the first shell, or a complete octet, meaning an energy shell filled with a complete of 8 electrons. Having such a compact structure makes them very, very hard to go forth and take part in reactions. As a result, they are unreactive or inert. So, the tendency of any element in the periodic table, eventually, if it has to gain a stable structure, is to somehow attain that state of inertness, that state of stability that these gases, that these elements by themselves have. In their case, they are made that way. They come that way. In case of in case of their elemental stage, but what about other elements? Say, what about sodium? Sodium, with an atomic number of 11, we can see, or we can deduce, that sodium has an electronic configuration of 2, 8, and there's one more electron that is left. Being left with one electron in the third shell doesn't quite allow it to have that much stability as neon would have or as helium would have. It needs to do something with this electron. Same with other elements. For example, magnesium has an atomic number of 12, giving it a configuration of 282. So, this element also has an extra of 2 electrons on its third shell, as a result of which it does not have quite the structure that helium or neon could have. They need to do something with these electrons. So what they do is they form a sort of a bond, a sort of this arrangement with another element in the periodic table. And as such, they either give away the electrons. In the case of sodium and magnesium, them being metals, they give away the electrons, these extra 1 or 2 electrons, to other elements that might need the electron in order to gain that complete octet and stable electronic shell structure. And as does, it forms a bond. This bond, this chemical bond, is what allows elements like sodium and magnesium or other elements like chlorine or oxygen or hydrogen to form a structure that is stable like that helium forms or neon forms by themselves. Now this chemical bond that these elements tend to form, they are of 2 types. The 2 important type of chemical bonds that we will discuss in this lecture is number 1, covalent bond, number 2, ionic bond. Covalent bond is a kind of chemical bond that is usually seen in between nonmetals. And ionic bond is a chemical bond that is usually seen between metals and nonmetals. Let's begin this part of our lecture by discussing covalent bond. So what is a covalent bond? Like I said, a covalent bond is a chemical bond that is formed when 2 nonmetals somehow form a bond between them. Now let's discuss this somehow. Somehow doesn't happen magically in chemistry. In this case, in a covalent bond, a nonmetal, let's say hydrogen. Hydrogen has hydrogen has an atomic number of 1. 1 is not exactly a complete duplet now, is it? So in order to fulfill a complete duplet, what it does is it needs another electron in its shell. 2 electrons, stable structure, and thus it can be free. So how does it gain that extra electron? What it does is that it kind of shares, it forms a bond of sharing with another hydrogen atom. Another hydrogen atom with 1 electron on its outermost shell shares its electron with it, not give away, but share it. And with that sharing, this hydrogen atom with 1 electron denoted by the cross mark forms a bond with another hydrogen atom having 1 electron on its outermost shell denoted by the dot. They're sharing these electrons and forming a bond within themselves. The bond is known as a covalent bond. This bond between them is known as a covalent bond. And this forms a hydrogen molecule which has a formula of H2. So this is a hydrogen molecule wherein two hydrogen atoms are strongly bonded within each other by a covalent bond. In my previous lecture, in the previous chapter, I mentioned that their elements can form molecules when they are bonded strongly within each other. And I mentioned that in the next chapter, you will be clarified how and why. So there you go, guys. You can see that one electron on the outermost shell of hydrogen is being shared with another hydrogen atom. Thus, they are forming a molecule with a formula H2. It is known as a diatomic molecule. Diatomic H2 molecule. Di means two. They're bonded together, forming a molecule. Now, if this were two lone H, I wouldn't call them a molecule. I would just say that they are two separate hydrogen atoms. Now, does this happen only in case of small elements like hydrogen, or does this happen in case of other elements as well? Or does this happen only in case of elements? See, covalent bond is a bond that happens mainly due to electron sharing. So it is not limited to hydrogen as well. Covalent bond can be seen in most diatomic molecules, diatomic element forming molecules. For example, oxygen. Oxygen and carbon, we know that carbon is in group 4. So the electronic structure of carbon is 2, 4. So in order for it to form a stable structure, it needs 4 more electrons in its outermost shell. This is carbon, an atom of carbon with 4 electrons. In order for it to gain stability, it needs 4 more electrons. Now, how does it do that? We have seen carbon forming compounds with oxygen with hydrogen. So let's discuss one such compound. Say methane, for example. Methane has a formula of CH4, wherein one atom of carbon is bonded with 4 hydrogen atoms. Now, if we look into the structural formula of methane, we'll see that the outermost shell electrons of carbon are being shared with 4 atoms of hydrogen, quite like how hydrogen atom shared its outermost singular electron with another hydrogen atom, forming a diatomic molecule. In here you can see that the hydrogen atom shares its outermost shell electron with carbon. Let me draw the structure for you so that you can understand it even better. So you can see here that each of the outermost 4 electrons are being shared with 1 atom of hydrogen, and these atoms of hydrogen are lending or sharing 1 atom each. Thus 4 and 4 making a complete octet, forming a compound which is much stable than a single atom of carbon. So this is the diagrammatic and a simple explanation of how covalent bond is formed. We can see covalent molecules almost everywhere. Simple covalent molecules are what gases. Simple covalent bonds are what gases are made up of. What kind of gases? Almost everything that we can find, each and every one of these gases we can find in our atmosphere. For example, hydrogen, oxygen, nitrogen, etc., etc. These are the gases that we can find in our atmosphere. Each of these gases, as you can see, are diatomic molecules. So a single atom of hydrogen can't exist freely. It is not stable. it has to pair up with another hydrogen. How does it gain such a structure? By forming a covalent bond. Same with oxygen. In case of nitrogen, it's a little bit complicated because of nitrogen's own structure. What happens is nitrogen also forms a diatomic molecule with another nitrogen atom. However, the bond between a nitrogen and a nitrogen molecule, there are 3 covalent bonds. The mystery behind these 3 covalent bonds is something that you will be clarified when you're studying organic chemistry. But for now, we have to study the fact that a nitrogen atom is bonded with another nitrogen atom by 3 covalent bonds. And these covalent bonds, these 3 make nitrogen a much stabler molecule than any of these gases, which is why nitrogen gas is usually so hard to react. It is harder to break nitrogen gas down and make it react with water or any other gases, which is why nitrogen gas in the atmosphere tends not to bond with oxygen or hydrogen, forming harmful gases. Like if nitrogen bonded with oxygen, it could have formed a harmful gas such as NO2 that is usually found in car exhaust fumes or industrial fumes. Or say if nitrogen were to combine with H2, it would have formed a gas called ammonia, which is also harmful. If nitrogen and hydrogen or nitrogen and oxygen mingled and reacted freely within each other. But it doesn't happen because of the strength and the stable bond between two nitrogen atoms. The only thing that does happen with nitrogen, however, is that during lightning, when lightning is happening, thunder and lightning, the extreme energy, electrical energy, causes breakdown of these bonds, and then nitrogen combines with water, rainwater, and it forms nitrous and nitric acids. And this is a fun fact, guys. Whenever you're studying biology, if you ever come through the nitrogen cycle, or if you ever come through chapters such as ecosystem, you'll get into it even more. But this is a fun fact that when thunder and lightning happens, this bond is broken down. Nitrogen combines with rainwater, forming acids like nitrous acids and nitric acid, which the soil absorbs and which our plants and everything uses to produce proteins. But we'll delve into that later in our biology classes. So, coming back to covalent bonds, we discussed the bonding in hydrogen, we discussed the bonding in oxygen, nitrogen, and also we discussed methane, CH4. Now let's see a little bit more of covalent bonding. So, hydrogen gas often reacts with chlorine to form a gas, effervescent solid actually, which is known as hydrogen chloride. If you mixed hydrogen chloride with water, what you would get is hydrochloric acid. And this hydrogen chloride compound is a covalent compound. How does that happen? What does happen actually? This is the covalent bond that we are going to discuss right now. So, chlorine has an atomic number of 17. Its electronic configuration is therefore 2, 8, 7. And we know that hydrogen is 1. So chlorine has 7 electrons in its outermost shell. It needs 1 electron to gain that 8 full stable structure, or the octet. So what it does is, if this was the outermost shell of chlorine with 1, 2, 3, 4, 5, 6, 7 electrons, it needs only 1 more to have that complete octet. So what it does is that this chlorine atom shares an electron with hydrogen atom. Hydrogen, having its singular electronic configuration on its outermost shell, shares that electron with chlorine, and the two therefore forms this covalent bond wherein they form this compound known as hydrogen chloride, which is white in color, by the way, and this is the bond that is formed between them, and this is an example of another covalent bond, another covalent structure. Examples of covalent bond are lying everywhere, from large covalent bonds with molecules such as large covalent bonds between a complex structure of molecules. For example, say butane, C4H10, 4 carbon atoms sharing electrons with 10 hydrogen atoms, forming a big structure, everyone joined together, sharing electrons in a covalent bond. Also, simple structures such as carbon dioxide, wherein a single carbon atom is sharing electrons with 2 oxygen atoms, forming a simple gaseous structure with a covalent with the atoms joined by a covalent bond. So these that I just discussed is the procedure how a covalent bond forms, mainly by sharing of their outermost shell electrons. And these outermost shell electrons are also known as valence electron, and the outermost shell electron, valence electrons, also gives rise to what is known as the valency. A valency is, you will often hear the word valency in chemistry. Valency means, say, sodium having an extra 1 electron that it can lose will give, therefore sodium has an extra electron in its outermost shell. This gives sodium a valency of +1. Why? Because it can lose this electron. And in case of chlorine, chlorine has an outermost shell fill up of 7. So what? It's valency 7? No. The trick is that the valency is how much electron you can either gain or you can either lose. So chlorine has 7. It needs to gain 1 more. Listen to me carefully. Sodium has to lose 1, so it has a positive valency, and chlorine has to gain 1, so it has a negative valency. And chlorine's valency is therefore -1. So let me repeat myself again. The valence electrons are also known as the outermost shell electrons of any element. The outermost shell electrons of any element gives rise to what is known as its valency. A valency of any element will depend on whether it will gain an electron or whether it will lose an electron. The valency of sodium is +1 because it has 1 extra electron that it can lose. And the chlorine and a chlorine ion will have, a chloride ion will have a valency of -1 because it needs 1 extra electron to gain a complete stable structure. That electron it gains, and when it gains that electron, it does so by forming a bond. Now, this bond that it forms is a little bit different than that of a covalent bond. How so? This is something that we will discuss in this part of the lecture. So, like I said, sodium and chlorine, 2 different elements of the periodic table. They form a bond within themselves, forming a compound known as sodium chloride, which we use every single day in our house, which is also known as the common salt. So, in the previous parts of this lecture, I have been discussing covalent bond. Now, is covalent bond the covalent bond is the reason why sodium ion and chloride ion are bonding between each other? Not so much. Sodium and chlorine, they are forming what is known as ions, as I have been saying so far. What are ions? An ion is a structure that is formed when an atom, say in this case sodium, when an atom either gains an electron or loses an electron. Sodium has an extra electron in its outermost shell. When it is able to give away this electron, the amount of total electron in its structure has one less. So it will attain a positive state. Why? Because it has a loss of electron. It has one less electron than it used to. There is an imbalance of total number of protons and electrons in its structure. The particles don't balance each other out. And since it has one less electron than it usually used to have, the number of the negative charge is one lower than the total positive charge. So sodium gains a positive charge, making it a sodium ion. Now metals in the periodic table, each and every metal in the periodic table that you can find on the far left corner, all of them forms positive ions. What about nonmetals? In here, a chlorine atom has 17 electrons. It needs one more. So what chlorine does, it accepts one electron from a different element. In this case, it will be sodium. That electron that sodium just gave away, chlorine accepted. It's kind of like if you needed to borrow, or say if you were short of a couple of bucks and you really needed that money to say you needed 10 bucks and you asked your friend for that amount of money and he gave it to you. So he's your friend, or he is the one that lent you the money, and this relationship that you guys formed between each other, the one of lender and that of borrower, is because he gave you something that you needed. In this case, sodium lent that electron to chlorine, forming a chloride ion. A chloride ion has an extra negative charge. Why? Because in a chlorine atom, the protons and the electrons balanced each other out. But the extra addition of an electron giving it a stable structure elevated the number of electrons, giving a rise in its negativity, therefore making it a negative ion. And when this happens, these two ions, the positive and negative, being of opposite charges, and we know that like charges repel each other, unlike charges attract each other. So these being of unlike charges will attract each other, forming a compound known as sodium chloride. So sodium chloride is a compound that is formed because two ions of opposite charge are being attracted to each other by a strong electrostatic force of attraction. The electrostatic force of attraction is arising because sodium is giving away its outermost shell electron and forming a sodium ion, and chlorine is taking that electron and forming the chloride ion. Therefore, the sodium ion and the chloride ion are bonding between each other, forming sodium chloride, and this bond that is allowing all this to happen is known as ionic bond. Ionic bond is the kind of chemical bond that happens mainly with metals and non-metals. In case of covalent, we have seen that it is a bond that is prevalent between non-metals only. But this bond, ionic, it happens mainly between metals and non-metals, chiefly because metal forming positive ions and non-metals forming negative ions. The criteria of an ionic compound is that it must have, the atoms of an ionic compound must have an electrostatic, a force of attraction wherein there is positive and negative that is pulling each other. And in order for that to happen, we need opposite charges. And in order for that to happen, we need metal and non-metal. So is sodium chloride the only ionic compound that we know of? Not quite. Compounds such as magnesium oxide, aluminium oxide, calcium chloride, calcium oxide are also examples of ionic compounds. For example, magnesium oxide has a formula of MgO. Herein, magnesium is the metal and oxide is the non-metal. Magnesium has an ion with the formula Mg2+, oxide is an ion with the formula 2-. Now, if we tabulated the charges +2 and oxygen -2, they cancel each other out, forming the stable magnesium oxide. This way we can see the charges, they balance each other, thereby forming a compound because of the attraction of the opposite charges, which is far more stable. In case of another example, for example, aluminium oxide. Aluminium oxide has a formula of Al2O3. So aluminium forms an ion with a valency of +2 then. Not quite. Aluminium is found in group 3. So, as we know, the group that an element is found in tends to give it its outermost shell electron number. And since aluminium is a metal, so being a member of group 3 gives it a valency of +3. So aluminium has valency of +3, forming an ion of +3. What happens in case of an oxide ion, an ion of oxygen? In case of oxygen, it forms an ion of -2. So it needs 2 electrons to form a complete octet. Why would it need 2 electrons? That's because it is a member of the group 6 of periodic table. Being a member of group 6 allows it to have, or gives it an arrangement of 6 outermost shell electrons. Thereby, it needs 2 more electrons to gain a complete octet. Since it gains both those electrons, therefore it has a valency of -2. So in case of aluminium, if we did a little bit of math between the charges here, aluminium has +3, oxygen has -2. The charges, they don't balance, they are not in equilibrium. So in order for them to form a stable ionic compound, these charges has to balance each other. How does that happen? If you multiply, or if you put in each aluminium ion has a charge of +3. So if you put in 2 aluminium ions instead of 1, you will find an overall charge of +6, right? And in here, 1 oxide ion has a overall charge of -2, right? So if you put in 3 oxide ions, instead of 1. Let me repeat myself. One aluminium ion has a charge of +3. So if you put 2 aluminium ions instead of 1, you will have an overall charge of +6. And in here, one oxide ion, an ion of oxygen, has an overall charge of -2. So if you put in 3 oxide ions instead of 1, you will find an overall charge of -6. Now guys, these two can balance each other out, cross each other out, because they're of the same value but of opposite charge. So we have aluminium atom that are 2 in number, and oxygen atom that are 3 in number. That is 2 aluminium ion and 3 oxide ion that was able to form this strong bond between one another because of their opposite charges. Because of the opposite charges their ion formed, they were able to form this bond with a strong electrostatic force of attraction, leading to the rise of an ionic bond. And therefore, the formula in here is Al2O3. So in chemistry or in any kind of bond formation, if you happen to stumble or if you happen to find yourself in a roadblock wherein you cannot understand why or how they're forming the kinds of bonds they are forming, you must do an equation, a simple mathematical equation or addition like this, where you can make sense of how a chemical formula will happen by the number of ions they might need in order to form a balanced structure. So this is another example of an ionic compound, and this is how they're being formed. And in this way, ionic compounds are generally being formed when positive and negative ions are attracting each other. Guys, now I will provide you a table with examples of some well-known metal ions and non-metal ions forming ionic compounds. Shows you the formula, the name and the formula of a few ionic compounds. As you can see, sodium chloride, the formula, sodium oxide, its formula, and etc. etc. Herein you can see the metal ions on each of these compounds. In here there's sodium, there's lead, there is potassium, and there's aluminium. And in here you can see all the non-metal ions that are bonding with each of these metal ions, forming the ionic compounds. The chloride ion bonding with sodium, forming sodium chloride, oxide ion with sodium, forming sodium oxide, nitrate ion forming with bonding with aluminium ion, forming aluminium nitrate. So this concludes Part 1 of our lecture in the chapter Chemical Bond and the Structure of Substances. In later parts, we will delve deeper into ionic and covalent compounds. We will see more examples of covalent compounds and how big these compounds and how big the bonds, covalent bonds can really form. Why the word and what the word giant or macromolecular substances are coined, and we will also see more examples of ionic structures, giant ionic structures, and we will also learn more about other type of bondings. But for now, I hope this part of the lecture was able to answer your basic questions about chemical bonds help you understand how two atoms form molecules by covalent bonding, what a covalent bond is, what an ionic bond is, what ions are, and what electrostatic force of attraction means, etc. Until the next part begins, have a nice day.